Welcome back to a new video. This video is going to be about tensors and tensor operations. This video is going to be one of the videos that I will be adding into the Deep Learning with PyTorch series. You can reach to that playlist from the cards of this video. Let's start coding. Tensors in the context of PyTorch are multidimensional arrays. Like if you ever worked with NumPy, you are going to remember arrays, and you can think like multidimensional arrays. These structures play a crucial role in representing data for neural networks. So at the first place, what I'm going to do is I'm going to import Torch, and then I'm going to select the kernel firstly. So what is Torch? So PyTorch, often referred as Torch, is an open source machine learning library developed by Facebook's AI research lab. It's widely used for deep learning applications, providing a flexible and dynamic computational graph, which makes it popular among researchers and practitioners. Okay, after the import, I'm going to create a one-dimensional tensor right now. I'm going to call it like tensor one-dimensional, and it's going to be torch, the tensor method, and we are going to give it a list like 1, 2, 3, 4, 5. And we can just print it like tensor one-dimensional, and we are going to see 1, 2, 3, 4, 5, and we can just call type tensor one-dimensional, and we are going to see that it's torch.tensor. Okay, now we know how to create tensors. What I'm going to do right now is we are going to explore basic operations with them. So let's create two tensors like tensor A, and it's going to be torch.tensor, and we will say 1, 2, 3, and tensor B, and it's going to be like torch.tensor 4, 5, 6. Great. So after that, at the addition side, we can directly add them like result, addition, and it's going to be tensor A plus tensor B. Straight like that. And I'm going to call it result addition right now. It's 5, 7, 9. So how we got that is 5 is the sum of the 1 and 4, and 7 is the sum of the 2 and 5 in here, and 9 is the sum of the 3 and 6 in here. So okay. At the subtraction side, we are going to have a similar thing. I'm going to say result, subtraction, and it's going to be result A, actually tensor A, minus tensor B. So when I call that, we are going to see that result subtraction, we will say minus 3 minus 3 minus 3, since 1 minus 4 is minus 3, 2 minus 1 is negative 3, and 3 minus 6 is negative 3. Great, so at the multiplication side, we are going to say something like result, multiplication, and it's going to be like tensor A multiplied by tensor B, like this, and I'm going to call it result multiplication. It's the same logic, great. So at the first place, we got the 1 times 4, 2 times 5 at the second place, and 3 times 6 at the third place. Great, so let's talk about matrix multiplication. What I'm going to do right now is I'm going to define two two-dimensional tensors, like I'm going to say matrix A. We can also call two-dimensional tensors as matrices, and I'm going to say like torch.tensor, and I'm going to give like 1 and 2, and then I'm going to call it like 3 and 4. So at the also I need to add one more bracket in here like this, so it's going to work smoothly right now. And I'm just going to call this like matrix A, and then we are going to see we have a tensor like this, and we can just call number of dimensions for checking the dimensions of it. Like when I call this, we are going to see 2, like actually I don't need parentheses in here. Great, so we have the 2, so it's a two-dimensional tensor. I'm going to call the matrix A again for you to see it. Great, so I'm going to define the second one like matrix B, and it's going to be torch.tensor, and we can say like 5 and 6, then we can say 7 and 8. And after that, I'm going to create something like result matrix multiplication, and it's going to be torch.matrix multiplication, and I'm going to give the matrix A and matrix B. And then I'm just going to call the result in here like this, and we are going to see that we multiplied these two matrices. Great, so let's talk about tensor reshaping. We are going to use this feature a lot. Reshaping tensors allows us to change their dimensions. This is handy when preparing data for different layers in a neural network. So what I'm going to do right now is I'm going to define something like original tensor, and it's going to be like torch.tensor. It's going to be a matrix again, 1, 2, 3, and then I'm going to say 4, 5, 6, and then I'm going to say reshaped tensor, and it's going to be original tensor. That view method we are going to use, and I will say 3 and 2, and after that we can just print original tensor, and we can print reshaped tensor. So you are going to see the difference right now. So let's talk about indexing and slicing. Indexing and slicing allows us to access specific elements or subtensors within a larger tensor. So what I'm going to do is I'm going to create something like tensor indexing, and it's going to be torch.tensor. I'm going to create a matrix again. I'm going to say 1, 2, 3, and then I'm going to say 4, 5, 6, and then I'm going to say 7, 8, and 9, and then I'm going to say, like, if I want to reach to an element at 1, 2, what I'm going to do is I'm just going to call firstly, and then I'm going to say like tensor indexing, and I'm going to use brackets, and I will say 1 and 2 in here. So we got the 6 in here, as you can see. Great. So at the first place you can think it like this is the 0, this is the 1, and this is the 2. And at the second place with this 2 in here, you can think it like we already selected this, and the 4 is the 0 element, 5 is the first element, and 6 is the second element. Like, remember that in Python indexes start from 0, so the first element is have the index number 0. So great, we can just change it, like if we want to reach to this 2, we can just say 0 for selecting this, and then we can just say 1 for reaching to the second element, which has the index number 1. So when I call that, we are going to see the 2. And if we want to reach to this 9, we need to say like 2 and 2. So we are going to access to it. Great. So we can also slice along rows and columns. Like we can just say tensor indexing for row indexing. I'm going to say 1 like this, and I'm going to see that we get this row and this row, not this one. If I just say 2, we are going to get the last one only. Yeah, like this. And you can just slice the columns like that too. I'm going to say tensor indexing, and I'm going to say like this, and you are going to see that we are going to have this 2 in here. If I just change the position like this, you are going to see that we are going to have the last one only. Great. So let's talk about reduction operations. Reduction operations allows us to compute aggregate values from tensors, such as sums or means. So what we can do is we can just create something like tensor for reduction, and we can say torch.tensor, and we are going to create something like 1, 2, 3, and then 4, 5, 6, and then let's say we want to get a sum along a specific axis. So for that we can just call torch.sum, and we can say tensor for reduction, and we can set the dimension as 0. So we are going to get, also let me quickly just call the tensor for reduction for it to be more clearer, and great. So we get like 1 plus 4, 5, 2 plus 5, 7, and 3 plus 6, 9. So if I change this dimension to 1, you are going to see that we are going to have 1 plus 2 plus 3, and we got 6, 4 plus 5 plus 6, we got 15. So great. Okay, let's talk about concatenation. Concatenation is useful when combining tensors along a specified dimension. So I'm going to say like tensor concatenation 1, and it's going to be like torch.tensor, and I will give 1, 2, and then I'm just going to add a bracket in here for, and then I will say 3 or 4. I'm going to add a bracket at the end too, because I don't want to get any errors. I will say tensor concatenation 2 this time. I'm going to create something like torch tensor 5 and 6, and then I'm going to say 7 and 8. And after that I'm going to call both of them like tensor concatenation 1 and tensor concatenation 2. And you can see that we have two matrices 1, 2, 3, 4, 5, 6, 7, 8. What I'm going to do is I'm going to use torch dot cat, and I will say tensor concatenation 1, and I will say tensor concatenation 2, and then I'm going to set the dimension as 0, and what we are going to get is it added the second tensor to below of this, the first one, and we can say 1 3 5 7 and 2 4 6 8, and we can just change the dimension, and then it's going to add its right. Like when I call this, you are going to see that it extended like this, and I'm just going to change this to 0, and I'm going to show you if you change this order, like you can just call the second one at the first place and the first one then, and you are going to see that the 5 7 1 3 6 8 2 4. So the order is important. It added to this one right now. So you can just change the dimension. It's going to result the same. So the order that you set is really important in this. Great. We also have a lot of element-wise operations in PyTorch. PyTorch provides a variety of element-wise functions, like exponentiation or square root. So we can just say tensor for functions. I'm creating tensors and tensors again for you to get familiar with this. I'm going to say torch tensor. I'm going to create something like 1.0, 4.0, 9.0 floats this time. And I'm just going to call like tensor for functions like this. And what I'm going to do is I will say like torch.exponentiation, and I will give tensor for functions in here. Like, let me quickly find that. Great. So after that, we are going to see that we have the values in here. We can also get the square root like torch.square root, and I will give the tensor for functions in here again. And you can see it's 1, 2, and 3, like from 1, 4, 9. Great. I also want to show you the random number generation. Like you can just call torch.random, and you can give like 2 and 3, and you are going to see that you will have a matrix since you specified 2 in here, and you have 3 per each in here. So you can just change this number like 1, and you are going to get a 1-dimensional 1. You can change this to 3 for getting a 3-dimensional 1. Great. So you can just change this to 4 for getting a 4-dimensional 1. And that's the way for generating random numbers on PyTorch. You can also extend this like 6, and you're going to get that. You can play with that as you wish. Like you can just change this like, let's say 4, and even if you don't change anything, if you just keep running this cell, you're going to get different random numbers each time. So it's a really useful function, and it's really used in deep learning. Okay, now I want to talk about broadcasting. Broadcasting is a powerful feature that allows operations between tensors of different shapes. Like what we can do is we can just say torch.tensor, and we can call something like 1 to 3. We can just call it like tensor broadcast 1, and then we can just create something like tensor broadcast 2, and it's going to be like torch tensor, this time with different structure like 4 and 5 like this. And what I'm going to do is I'm going to just add them like the normal ones, like tensor broadcast 1 plus tensor broadcast 2. We are going to see that we have a 5 6 7 6 7 8. So how this works is it just adds this and this at this side, first one, and 1 and 5 at the second side, and then 2 and 5 at the third side, and you can see how it changes. Great. So the last topic of this video is going to be Autograd automatic differentiation, which is going to be really useful when we are training neural networks on deep learning side. So what I'm going to do is I'm going to create a tensor like tensor for grad, and it's going to be like torch.tensor. I will give 2.0, and then I'm going to set requires grad true. And then what I'm going to do is I'm going to create something like result, and it's going to be tensor for grad. And I'm going to take the second power like this, and I'm just going to call both them like tensor for grad and result. You're going to see 2 and 4. So I'm just going to say result dot backward, and then I'm just going to say result dot backward, and then I'm going to say something like print gradient, and I will say tensor for gradient dot gradient like this. In the end we are going to see the 4. Great, so that was all for this first video. Thanks for watching the video. I'm sharing 2 or 3 new videos every week about data science and Python programming. You can subscribe to my channel for more videos like this. I shared a free data science bootcamp where I teach Python, Pandas, NumPy, Matplotlib, Plotly, Seaborn, and scikit-learn with 3 projects. The video is about 7 hours and it's completely free. You can just reach to that video from the cards of this video or the link in the description.